Okay, 9.1 conics, and we're talking about ellipses, and we are on example 4. So we're talking about eccentricity of the ellipse. Now, the eccentricity of the orbits of the planets, the orbits are ellipses. So if you look at it, they don't look like they're very big, right? They're pretty small. So Earth is 0.017. So I want you to think about what that would be. How is C, the value of C, going to be compared to A? So you get the C has to be pretty small, right? Almost to the center of a circle. So you can kind of picture the two distances we talked about, distance 1 and distance 2, that they're going to be pretty much the same, right? You're going to have that C right at the center, so right close to the center. So they're almost going to be two distances that are equal to D when you have it going straight up, if you know what I mean. All right, anyhow, we'll talk about that. All right, so we want to find the equation of the ellipse. I'm going to give up the pink rectangle here because I think it'll just work out fine if I don't use it. So we've got, in this case, we're finding the equation of an ellipse with just the information that's given. So you can kind of see we've got the foci at 0 plus or minus 8. So I'm going to plot those on the graph. The foci are given. You see them in pink dots, right? And then the E is equal to 4 over 5, and I want to sketch its graph. So E is equal to 4 over 5. Now think about this. E is equal to 4 over 5. E is equal to C over A. And I know that the foci are plus or minus 8. So then C being 8, then 4 over 5 has to equal, in that second step that you see here, 4 over 5 has to be equal to 8 right here over A. So then just solving that, we get 4A is equal to 40, then A has to be equal to 10. So if you look at it, I put a focus, I think I slid a little bit there, but no bother. So I have these two vertices. The vertices now are 0, negative 10, and 0, positive 10, okay? So with that, once we get our 10, then I've got to get my covertices. So I have my covertices at 6, 0, and negative 6, 0 from that next line, where I've got to find what is B. So I managed to use C is equal to A squared minus B squared, and I find B. Then I have my covertices, starting from the center, and I move 6 units out to the left and to the right. All right, so then I have B and A, so now I've got the equation of the vertice, of the ellipse, because in my equation, all I need is A squared and B squared here. So I have X squared over 36 plus Y squared over 100, squaring the A. I get is equal to 1, okay? And there you have it. There you go. Those are the 3 steps there. So here is a picture. Remember, we were talking about the sun, and that it is closest to the sun at the perihelion, and then it is furthest away from the sun when it's at the aphelion. You can imagine, when is the Earth furthest from the sun? And you can think about weather when the sun is further away versus closer as it goes around in orbit. You guys can see that, I'm sure. Okay, all right, so with that, okay, and the next one we're going to look at is we have a chart in 9.1 that you can look at to take a look at as we translate left and right, but we're going to have a center at HK that we're dealing with in this one. So let's just go over the steps that I have in here, and I think you'll probably be all right. So the first step that I go over is I say, all right, A squared is equal to 9 when I look at the equation. So this is the form of the equation up top. So I'll take it apart and say, oh, okay, well, this is a vertical axis because here's the y squared. So the y squared then is over top of the bigger number. So that means it's a vertical axis. Okay, so A is equal to 3 and B is equal to 2, right? And then I go ahead and I get the C, same way we did before. So I use this, C is equal to this equation. C squared is equal to A squared minus B squared, get the C. So it's going to be up, but you have to watch out because you're using numbers here. Notice I put the foci in, but I didn't really use it to graph the ellipse, okay? I put them there. I know that from the center, it's about 2.24 up and 2.24 down because that's the approximate value of square root of 5. 2.24 units from, make that a 4, from the center of the ellipse, okay? All right, so, and I have those values down here. So we get the center on, we have the vertices, and the covertices are formed by using the values 3, going from the center, -1, 2. I go 3 up to -1, 5, 3 down from -1, 2, and I have these two vertices, okay? Then I get the co-vertices here. They're here, co-vertices. Starting from the center, I go over, now see the B value is 2, so I go over 2 units and I get to 1, 2, and then I go back to the center, go to the left for the co-vertice, -3, 2 is that point. And I just plugged what I have in here, and here are the answers. So you have to think, where's the center? I have to add and subtract the A's and the B's and the C's, okay? So there you have it on that one. Right, let's go to the next one. Oh, my goodness, is that the last problem? I thought I had another one. Okay, do we have example 5? And that's example 5, and I think that's a wrap. Okay, I thought I had one more application problem. Maybe that's in the wrap-up day, okay? So this is the lesson video for you guys to complete your writing and graphing ellipses. Have a good night, and I will see you when I see you.